Okay, so page 11 in your packet. Okay, so starting with number one, first thing we do is look to see, can we expand and distribute our way through this? But pulling out 5 parentheses is a lot. So our next option is U-Substitution. What could our U value be? Yeah, 5 is my score. Okay. I'm always going to underline what's in the parentheses and dx because I know those are the pieces that needs to be replaced. And my goal is to first make the problem easier looking, and second, trying to identify a rule that I can use. Make our substitutions. Pull the 1/5 out in front. So we're staring at an easier problem, and we have a rule that we can apply. Right? This is power rule. Matches perfectly. Okay, pull the 5 and 6 out in front. That's 1/30. And remember, U is only a temporary variable. Bring back your X.
Why don't you multiply by? Oh wait, never mind.
Mm-hmm. Yeah, 5 and 6. Yeah.
So when you bring that 5 over, it's still 1/5, not 5.
Exactly right, because it's in the denominator.
Okay.
Right. Okay, number two, we imagine what it would look like if we tried to expand this, but this is too big, right? Anything greater than 2, we don't want to play with. So use substitution. Focus on what's inside the parentheses. We always do du over d. Could be x, could be t, just depending on what the independent variable is. So we're always going to match whatever independent variable that we're trying to replace.
Would you set u over dt equal to 3t squared instead of 5? In other words, equal to 5. That's the exponent, then this one you set it to the coefficient.
Plus 4, 5, plus 4. Okay. Which part? Number 1 or 2?
I was wondering why you decided to set it equal to the coefficient rather than the exponent.
Which one?
2.
2.
2 for 3t squared.
I didn't. I found the derivative. It just so happened to look like that.
Oh, okay.
Yeah, it just happened to be the same thing, but I'm not looking at that.
Oh, okay. I was wondering why. Okay.
Hey.
Wait, is it this packet?
It's in my folder, I think it is. The last page.
Thank you.
Okay, solve for dt. Make my substitutions. Okay. T squared goes away. The 3 also happens to go away. So now I'm left with something that I can handle using power rule. Okay, number 3. Expand our way through. We try. If we think about trying to do that, we're going to get stuck. So maybe let's rewrite the problem. How can we rewrite this?
4x minus 5 to the 1 half.
Okay, pull the 1/4 out in front. So again, power rule. So 2/12 reduced to be 1/6. Okay, number 4. No way to expand this out. This is kind of stuck the way that it is because of square root and addition, subtraction inside the radical. So denominator, parentheses to the 1/5. X squared goes away. 5/3 out in front. Okay, now does this match power rule?
think so.
Okay.
There.
Is there any adjustment that we need to make before we can do power rule though?
To bring it up.
Yeah, we can never do power rule if the variable's in the denominator. If we try it, we're gonna end up with the wrong exponent. So we gotta bring that up to the top before we do power rule. Now this is a match. Okay. Add 1 to the exponents, -1/5 plus 5/5 is 4/5. Okay. Number 5. We have a cosine rule, but not cosine of 2x plus 1. So it should be pretty easy for us to identify the u value here. Okay, integral cosine of u, this we recognize. Cosine becomes sine. Then bring back your original variable. Right. Number 6 seems more complicated. There's multiple trig functions here, but I know we see a set of parentheses, but let me tell you something here. If you go through U-substitution, you're never going to do u equals x. Okay. The reason why is because you're not making any progress with that, right? No matter what the problem is, if you're trying to make the problem look simpler, and if you just make a straight 1-to-1 substitution, you haven't created an easier problem. You've made the problem look very similar with a different variable, but it needs to look significantly simpler than what you started with. Okay, so you're never replacing x with just u. All right, we need a larger piece for the u value. Maybe we can rewrite this problem. You see a way to rewrite this problem?
10.
Yeah, let's bring that 10 out. All right, we can always create a set of parentheses and brackets, a better visually, a better location for that 10. It means the same thing, but this helps us a bit more, right? Now we can potentially see that our u value is that sine of x. Sine's derivative is cosine. Grace, we're on page 11 of the old packet. Okay, we make our substitutions. Cosine cancels out. That matches nicely with power rule. Okay, questions with 6. I'll skip, well, I'll briefly start number 7 and 8. These are easier here because I think it's obvious to tell that the u is just that cosine of x and sine. Right. Here, what's our u value?
So
Yeah, 3x minus 7, once you bring that to the 1/2 out. Okay, so I want to go to number 9 here. Okay, this looks more complicated here. We're thinking, well, what if this 5 over x? Maybe it's the secant or the tangent or the 4 over x squared. So here's the thing is that if we can kind of imagine a rule that's going to come out of this, this kind of looks like if we imagine the 5 over x to be the u value, then maybe we can turn it into something like this. Right? If we can move towards this direction, is this a rule that's available to us? Yes, right. We know tangent derivative is secant tangent, so the antiderivative of secant tangent is going to be tangent. So we're going to target both these parentheses, okay? We want both these to be u values so that we can make, because we can kind of have a goal that we want to work towards. It seems kind of strange, right? It's like, how is this derivative going to produce something that will take this out? But remember, we're dealing with a negative. We got to bring that x up. We got to go through power rule, and anything in the denominator kind of has a different behavior than what you would expect. Okay, once you bring that up to the top. Okay. I want to find the derivative, but I don't want to go through quotient rule, so I'm going to push that x up to the top. And then I can find du dx. I'm going to clean this up first before I cross multiply. I just want to get that negative exponent a little cleaner here. Okay, cross multiply. Solve for dx. Okay, make my substitutions. Okay, how does that look to you so far? All right, I replaced the u, I kept my 4 over x squared alone, and I replaced the dx with what I found, x squared du over -5. Okay. The x goes away. Right, they do, right? So we know we're in a good shape if I get the x to go away. But there's a leftover what? Can I push out in front? 4 and
-5.
yeah, so -4/5, right? So -4/5 gets cleared out in front. And now this is a nice clean rule. X's goes away, coefficients, we're keeping track of them, but really the rule that we're after is that secant tangent, which becomes tangent. Sorry, becomes secant. My bad. Secant's derivative is secant tangent. So therefore the antiderivative secant tangent is going to be secant. Okay, number 10, what's our u value? Parentheses, right? 7 minus x to the 5th. Okay, also number 12 is pretty straightforward. What's our u value there?
Yes.
Yeah, 3 minus 2xq, right? These cannot be expanded, so go directly to U-substitution. Now, number 11. What about number 11 here? Anything different about this problem?
You can expand it.
Yeah, this is a power rule problem. This is not a U-substitution. Because everything is manageable, right? We can distribute this through, we can separate. There's nothing that's preventing us from distributing through and cleaning up, right? No radical involved. There's no messy denominator. There's only one term in the denominator. So I can split up into individual fractions, resolve each term, and get each term ready for power rule. So I converted the root x to be x to the 1/2, and I push the x up to the top. Resolve each exponent. 4 minus 1/2 is 8 minus 8/2 minus 1/2 is 7/2. 3 minus 1/2 is 6/2 minus 1/2, which is 5/2. And those are nice and clean power rule, right? All the fractions up top, 9/2 becomes 2/9. 2/9 times 2 is 4/9.
Today, I have a question.
Yeah.
So for number 9, let's say that both of the 5 over x, if there were both different values, what would you do?
That wouldn't happen because it wouldn't fit into any rule, right? Yeah, if it was different values, then we wouldn't be able to solve it. Yeah, because our rules our integral rules are so restrictive, right? If we go with the U-substitution, it's got to look exactly like one of the rules that we already know. If we can't make it look like one of the rules, then we're kind of stuck. But you won't ever see a problem where I give you ones that is not solvable.
It's a shame.
Okay. So yeah, very restricted in what we can give you as problems. Right, it's gotta find its way to work with one of our 7 rules, right? You got power rule and you have the 6 antiderivative rules, trig rules. Mhm.
Formulas. Sense.
Mm-mm. In the packet that you just picked up, it has the formulas that you need to be responsible for.
So it'll be like the quiz where you have that extra sheet with the.
No, because I'm not going to put those summations on the test. Yeah. I thought
I think it's at the very.
did I not include it?
Mine on the last page.
Okay, no, that's, well, those are the descriptions. But I also had yeah, that's good. This is a reminder that I need to print that out so that you can see what you're responsible for. But really, it's yeah. Really, the only rules you gotta be responsible for is power rule and the know your 6 trig derivatives, and which will lead you to your 6 trig integrals. Yeah. And also average value theorem. So we'll go over that, but this, yeah. So really, it's just one additional rule more than your quiz, but there's not going to be any summation on the test. Yeah.
Okay.
Yeah.
Thank you.
Mr. Yang, the last page of the packet, is all this gonna be on the version of the first part on Friday, or is this both parts combined?
This is just the Friday one. Yeah. So power rule, U-substitution, trig integrals, definite integrals. Make sure you know your unit circle values. We'll practice those. We haven't gone over absolute value functions. That's easy. You're basically just adding 2 triangles up. We'll go over that. Even odd functions, we talked about that. Second fundamental theorem calculus, average value theorem. And then given the second derivative, work your way up to the original function. We did that on the quiz. Yeah. So we've almost seen everything. There's just a few things that that we need to clean up, but yeah. Okay. Sorry, I have a meeting, so I need to have you guys come back later.